writing symbolic representations from a table, remember symbolic representation is the equation. So using numbers, symbols, and variables, how can you represent the equation? So this is the one that you should have done as your entry task, and it said create the verbal. So if you notice, from 8 to 12, there are 4 more. From 12 to 16, there are 4 more. From 16 to 20, there are 4 more. So for every length added in the pool, you have 4 more tiles. I went ahead and drew this out without you guys having to watch me. If you need this in your notes to help you, then go ahead and draw it in your notes to help you. So this one, notice, is a pool that has a 1 length, so it's 1 wide and 1 tall and 1 wide. So that's the length that it's talking about. So this one has a length of 1, and then the number of tiles is 8. So you have to wrap it all the way around. So 1, 2, 3, 4, 5, 6, 7, 8. This one has a length of 2, and then it has 12 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So notice it's covering the sides, and then it has the 4 corners. This one, there's 3 on covering each side because the length is 3, and then the 4 corners. This one has 4 on each side. There are 4 sides. 4 times 4 sides is 16, plus 4 more is 20. So that's where all these numbers are coming from. There are 4 more on each one of them because you have to add 1 to each side to make it. So from this one, there's only 1 on each side. This one has 2 on each side. So that's where the 4 more comes from. 1 here, 1 here, 1 here, and 1 here to add to the total number of tiles in the border. Okay, now if you notice on my table, I have an extra column that's called the process column. The process column is what helps you write your equation. So that's why you will see me write the process column. Let's go ahead and write out the definition for process. So the process is used to write the equation, and it is to get from the independent to the dependent. So mathematically, you can pause it if you still are writing that. Mathematically, how do you get from 1 to 8? And then it needs to be the same thing that gets you from 2 to 12 and 3 to 16. So, if you look at that, you could say, and I'm doing it, I'm going to be erasing, so make sure you do this part in pencil if you normally use pen. So I could say 1 times 8. Well, yeah, that gives me 8. Sorry, that green doesn't show up very well. So you could do 1 times 8. 1 times 8 gives you 8. Now you want to put the second length, so 2 times 8. This stays the same. The only thing that changes is your value from the independent. So 2 times 8 doesn't give you 12, so that doesn't work. Another way you could get from 1 to 8. Let's think. You could do 1 plus 7. 1 plus 7. But does 2 plus 7 give you 12? No. So that doesn't work either. The best thing to always do, you know that from 8 to 12 it went up by 4. From 12 to 16 it went up by 4. 16 to 20 went up by 4. So you can always do this number times this. 4 times 1. 4 times 1 is 4. Plus what would give you 8? So I want you to have that thought. 4 times 1 is 4. Plus what number would give you 8? Well, it would be plus 4. Remember, a minute ago I said it's 4 times whatever your length is, plus the 4 corners. So if you think about that, it's 4 times whatever my length of my pool is, plus the 4 corners will give me 8. Let's check it on the next one. 4 times 2, 4 times 2 is 8, plus 4. 8 plus 4 is 12. Okay, try the next one. 4 times 3 is 12, plus 4 is 16. 4 times 4 is 16, plus 4 is 20. So the first 4 came from 4 sides. This 4 came from the length, and this is the length right here. And then the plus 4 came from the 4 corners. So when you look at this table, or when you look at the process column, you always want to do 4 times or some number times the input plus whatever will give you your equation. So now, to use variables in this, if you notice, the 1, the 2, the 3, the 4 were changing. So that is your variable. You always use whatever value is changing and you represent it with a variable. So my final equation here would be 4 times, let's use L for length, and I'm going to do it a cursive L just so that it doesn't look like a 1. So 4 times L plus 4 gives me my number of tiles. So it's 4L plus 4 equals however many tiles. So that is your symbolic representation. Okay? So again, if you need to, you can pause that. I'm going to erase it to do another problem. Okay. Number of squares. Again, put the process. And then number of sticks. So this one I'm going to be doing is the one that you had on that matchsticks activity. A couple of people were able to get the equation, some were not, and I told you that was fine. I just, oops, I'm not spreading it out enough. And 13. So the matchsticks problem, if you remember, the first one looked like that. The next one looked like that. This one looked like this. And this one looked like that. So there are 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry, and then 13. So if you look at that, again, find out how much it's increasing by. So each time there are 3 more sticks. And those 3, oh, I don't want to do it on that one. Those 3 sticks are coming from right there. So we have that initial one, or the very first one, and then there are 3 sticks to finish off the square. So every single one of them have this very first stick. So to write our process column, this number right here is what you multiply by. So it'd be 3 times 1. So 3 times 1 is 3. And then you just need to think about plus what would give you 4. So plus 1 gives you 4. So 3 times 1 is 3 plus 1 is 4. Okay, I'm going to do the next one. 3 times 2. 3 times 2 is 6 plus 1 is 7. So it looks like this is going to be our equation. 3 times 3 plus 1. 3 times 3 is 9 plus 1 is 10. Sorry, my computer logged out. And then 3 times 4. 3 times 4 is 12 plus 1 is 13. So that is our equation. This 3 is from how many more? Is the number increasing? The 4 is the number of squares. And then the 1 is the original. So the main thing you want to look for is the number increasing by in the pattern is what you multiply by. Okay, so our final equation on this one is 3 times the number of squares. I'm just going to put S for squares plus 1 equals the total. I'll just put total. You can also, you will see them also written as 3x plus 1 equals y. Remember, x is the independent, so this one, and y is the dependent. Okay, so that is that's the last example I wanted to do. On your assignment today, you are going to need to copy the table out of the problem and then paste it in the text box. If you need help with that, you need to ask, because if you do not do it right, you're going to get marked off. So whenever you do this, for my process column right here, I would do 3 times is if you hit Shift 8. Shift 8 will do that little asterisk that looks like this. And then 1 plus 1. And then on the next one, you would do 3 times 2 plus 1, 3 times 3 plus 1, 3 times 4 plus 1. And then it tells you to write the equation. Make sure you actually write your equation out. Remember, I didn't write it 3 times S because a number and a variable right next to each other imply that it's multiplied. So it would be 3S plus 1 equals T. So when it asks you to write the equation, that's what you do. You have to do both parts. Copy this table, create the table, and then give this equation.